All right, so let's just put convection currents in the back of our mind for a minute here. They're not going to go away. But we are going to talk about real quickly about some other phenomenon that we're going to try to explain later on. So this video is going to focus on the concept of drifting continents or continental drift. Um, so the world map has changed throughout the years, at least that's what we come to agree, and people were wondering at the whole start of this whole investigation why the coastlines of several of the continents pretty much looked like they fit together. And if you look at the little GIF here, it'll come back together eventually. Um, and it does show some of the things we're going to talk about. So here we do have our continents today, and they are merging together in that little GIF. And you see how they kind of just fit right into there. Not perfectly anymore, but they did at one point. So this theory that is going to come up is called continental drift, and it's going to be made by, or proposed by, this German scientist, Alfred Wegener. Yeah, the W does sound like a V. He is German. He's going to hypothesize that all the continents were once joined together in a single landmass and have since drifted apart. He does have some evidence to support this theory, but in his time period, it's really not going to be considered a viable option until the 1960s, when we get a little bit more evidence on how this occurred. So he does name his supercontinent Pangaea, which you probably have heard the name Pangaea before. So Pangaea existed about 300 million years ago. This is about the same time reptiles and winged insects first appeared. It was pretty much covered in tropical rainforests, and if you know anything about coal deposits, these tropical rainforests are going to die, and their organic material is going to be covered by dirt and ash and rock, and eventually all of the organic material is going to be compressed into coal deposits, and that's where we're getting our coal from these days. Over tens of millions of years, the continents then broke apart and they moved to their present location. This is known as the theory of continental drift. So here again, just an image of Pangaea at the front. Here's Pangaea about I don't know, this one's saying about 225 million years ago, which is pretty close to 300 million years from the grand scheme of things. And that sense has moved apart into roughly what it looks like today. Even today, they are still moving about as much as your fingernail grows, but that's still movement. Wegener is going to publish evidence in a book called The Origin of Continents and Oceans, and he's going to have three main focuses for his evidence. He's going to talk about landforms, fossils, and climate changes in different areas. So let's look at those. Let's find some examples of what Wegener is going to actually cite. So let's start with landforms. He's going to notice that mountain ranges kind of line up. If you were to stick those continents into like the places you think they would fit, it looks like they fit into, you get mountain ranges that kind of line up. So here we have the Appalachian chain over here, and then we have some British Isle mountains and Scandinavian mountains over here, and when you put them together, the chain kind of just lines up. So he's thinking, well, that's evidence to say that, hey, these were once together and formed the same mountain range. He's also going to talk about coal fields, on how they match similar coal fields in North America. Will also match with ones over in Europe. So you get similar landforms if you match them up. Next thing he's going to look at is fossils. Fossils are any traces of ancient organisms preserved in rock. Two main ones he's going to look at is the Mesosaurus and the Lystrosaurus. Were found in similar places. If you push the continents together, they kind of line up where they were found. However, nowadays, due to the fact that the continents aren't together, they are separated by oceans, which these animals, these early ones, were reptiles and were not capable of swimming large distances, especially in salt water. That is the distance of an ocean, that is. Another fossil he's going to look at, because again, fossils are just ancient organisms, so why can't we look at plants as well, is the Glossopteris. Glossopteris. the pronunciation keys in the book. But it is pretty much a fern-like plant. And they've been found in a lot of the continents, even though these fern-like plants reproduce through spores, and that's a very weak way of traveling. They can't make it across the oceans to reach the different continents as it would be today. But if they were all together, that would be a pretty simple task for them. Last one he's going to look at is climate change. He's going to look at fossils in different areas, such as Spitsbergen, which is an island in the Arctic Ocean. This island was found to have the remains of tropical plants, and tropical plants don't really exist in the Arctic due to the fact that that's an Arctic climate, not a tropical climate. So he's also going to look at that, as well as deep cracks in South Africa's rocks are going to show that there's evidence of glacier movement. And again, South Africa is nowhere near where glaciers should be. But if it was moved somewhere else, it very well could have been. Like I said at the beginning, scientists are going to reject Wegener's theory. I spelled his name wrong. It's W-E-G-E-N-E-R. But Wegener is going to provide the evidence that says, hey, they were together, but he cannot give an explanation on how the continents move. So if the continents aren't moving, then, or he's not giving how continents move, then they're not really going to accept that they were put together.